right?
Okay, so thank you again for joining for this very first Flight 7 webinar. And we're going to have a special guest, which is Global Coordinates. And they are going to be taking over to explain a little bit about terrain and obstacle data. So if you haven't heard about Flight 7, that's the startup company that I'm having for a few years now. And we're doing aeronautical charting, instrument flight procedure design, aeronautical information management, etc. But as part of our bigger initiative, we want to bring information to the world so that they can improve on what they're doing. And we are also bringing in experts from different fields so that they can tell us about, their expertise. So I know a little bit about terrain and obstacle data myself, but I don't collect it and I don't process it directly. So I always try to bring experts on the field. So today we're going to have Aparna joining us with her team. But before we go over, let's see, from where do you join us? So I see that we have a lot of people from South America, have some people from Africa, Europe, Asia. Also, be free whenever you want. You can ask questions via the chat function, okay? Or if you want, at the end, of course, you can also ask to have your question live. So without further ado, let's share the results. So we have a lot of people from South America and Africa at the moment and Asia. Okay, so let's go on. And like I said, we're going to have a Global Coordinates team here. Aparna, if you can say hi, open your camera and just say hi there to everybody.
Okay.
Hi, and she's from India, attended PenSub's course at Singapore Aviation Academy a while ago. She has worked on the field of integrating technologies for GIS and aviation safety, working with stereo satellite imagery since 2012 for the extraction of terrain and obstacle data using photogrammetry, and worked on the creation and development of TOD for a pilot area around IGI Airport, which can be found at, I cannot pronounce that, but that's an interesting name that you have there. And I'll give you time to explain that later on. So I'm just presenting your team at the moment.
Okay.
Then we have Yoti Najal, which is a master's degree in geoinformatics, associated with Global Coordinates with the TOD project, and also other GIS projects. So hi, Yoti. Thanks for joining us today.
Hello.
We also have Hemraj Pandey, bachelor's degrees in geomatics engineering, and associated with Global Coordinates for the development of the Geo Portal. So hi, Ham. It has been a pleasure meeting you.
Hello,
and
everyone.
Finally, we have Vinaj Dahija. I don't know if he has joined yet, but he has a software architect with 12 years of experience in India and in the UK. So I hope that you're ready. And if you have any questions, remember that you can do it via chat, or you can raise your hand and I can give you the word so you can ask your question live. This recording is going to be available later on our YouTube channel so that you can watch it again if you want later on. And please share with all of your associates and colleagues that we're doing this type of, let's call it, training events and so forth. So, Aparna, now
Yes.
We're going to be talking about terrain and obstacle databases and India case study. So I'm going to give you the floor so that you can take over now. And as I said, if they have any questions, I'll try to moderate and I'll be here on the backstage. But now it's time for you to do the presenting.
Thank you, Antonio, for facilitating this webinar for us and this opportunity to present what we have done. Good morning, good afternoon, good evening, because we have joined from various parts of the world, and it is a great honor for me to present what we have been working on for the past several years, since ICAO has mandated that all international aerodromes have to create digital data sets based on the guidelines published in their documents. So just a small introduction about the documents that we have used. Antonio has already introduced us, and so I would not like to spend too much time on that. We are definitely presenting a case study in the context of ICAO, and of course for India, we have followed the guidelines published by DGCA, which is the Directorate General of Civil Aviation in India. The documents published by ICAO are the PANS AIM document 10066 and document 9881, which clearly states that we have to use GIS to produce digital terrain, obstacle, and aerodrome databases for producing aeronautical charts or supporting aeronautical applications. So here there is a small difference between a digital data set and an electronic data set. And a digital data set is an electronic database, but an electronic data set is not a digital database. And this presentation will be given to you after the webinar, so you can read the text. I'm not reading it. But essentially, in a digital data set, we have a spatial component and we have a non-spatial component. And when we add the two using an obstacle ID or any ID, it becomes a digital database. So that is what we are going to demonstrate with the presentation and also live. Here I want to mention that we had done a pilot project for International Delhi Airport, but it was very, very cost intensive. So we created the database using photogrammetry and using stereo satellite images. And the cost per square kilometer of creating that database was extremely high. And I think it is the extremely high cost of creation of these data sets that is a big deterrent for most international airports in creating these databases. So for Mumbai in India, what we have done is that we have used data mining, and we have used existing database already published by the Airport Authority of India, which is in the form of AIP, which is the first half of the slide. And we have used the NOCs, which are already published. So these are databases which are already published by most civil aviation authorities. So we do have the AIP, which publishes surveyed obstacles, and we do have the NOCs, which is the no objection certificate issued for any building which is being constructed within an area of 20 kilometers for this country, and maybe in your country, it is some other guideline. So this is the flow chart, which I'll try to go over quickly in how we have used data mining. So we have used two data sets. We have used the obstacles published in the AIP, and we have used the data set of all the aeronautical studies conducted for giving more height to existing obstacles. So when an aeronautical study is conducted, it definitely means that the obstacle is already penetrating the obstacle limitation surface. So if it is penetrating the obstacle limitation surface, by definition, it becomes an obstacle. So we have taken these two data sets and we have plotted them in GIS environment. And we have used ArcGIS software, which we will be showcasing later. And what we have done is that for the same area, we have taken a high resolution satellite imagery, and we have plotted the points over the satellite imagery and then captured the building polygon, whatever is the boundary of the obstacle from the satellite image, and then divided the obstacles into various areas and then calculated the penetration. And that has been used to create the attribute data, which is then linked to the spatial data. So I'm just showing you a sample of the approach surface, the approach, takeoff, and IHS. So these are the obstacles that have been captured, which in GIS environment. And the zoom level is not too much, so you can see them as points, but there are a lot of polygons, and we will be able to show them to you soon. So based on the data mining, we have been able to capture 4,401 obstacles within the 45 kilometer radius from the ARP. And this by no means is exhaustive. Definitely, if we were to follow the exact guidelines from ICAO, there would be many more obstacles. But as a first cut, as a first version, just capturing the obstacles published in the AIP and the NOCs, which have gone for aeronautical study. It gives us a starting point. It doesn't cost too much, and we can plot this in QGIS, and it becomes a very cost-effective way of starting with the first version of the digital obstacle data set. We are focusing more on the obstacle part this time because it will take too much time to cover both terrain and obstacles. So we are trying to focus on the obstacles in this webinar. Okay. The other thing that we noticed was that there is a lot of overlap between the areas defined by ICAO and the areas that are mentioned as the obstacle collection surfaces. So there is an overlap. And so we have created permutation combinations, and we have highlighted areas which are common to both. And we have divided the obstacles into these common areas so that the calculation can be done based on both surfaces, for obstacle limitation surface and for obstacle collection surface. And we have added the attribute based on the calculation for both. So according to us, all the areas have been divided into 13 areas, 13 geographical areas. So if you see the combination here, we start with area 2A, which is the strip area. Then we have a combination where we have approach, IHS, and 2B. So approach IHS is a category of OLS, and 2B is the category of OCS. So I hope we are all familiar with obstacle limitation surface and obstacle collection surface. Then we have inner conical approach and 2B. Then we have approach OCS and 2B. And then we have approach takeoff IHS 2B, approach takeoff ICS 2B. So the first part is the OLS and the second part is the OCS. So we have taken these, and like this confusion exists. I mean, I'm not sure why ICAO has defined obstacle collection surface while we do have obstacle limitation surface. So I think going forward, ICAO may decide to give us a more easy way of, defining the areas where there is no confusion. And I believe there is a OLS task force team, which is now designing new surfaces based on obstacle evaluation surface and obstacle free surface. And that may happen in a couple of years. So as of now, I'm not sure which country is following which surface. So we have done this case study for India, and for India, obstacle limitation surface is mandatory and obstacle collection surface is only recommended. So these are the areas in which we have divided the obstacles. I also want to show how we have captured the polygons. So when you see the point data, which has been plotted from the AIP at the top, we have overlaid this over the satellite imagery. This is a Cartosat 3 MX 1.2 meter resolution satellite imagery. And when we plot the points on this, we have captured the polygons from the satellite imagery. So this actually reduces the cost of manual surveying. So if we were to go on ground and actually do the survey of each building, then it is going to be a very cost intensive and a very time consuming affair. Also, if we were to use LiDAR technology or drone technology, it really raises the cost. So we found this a cost effective way of getting the building boundary. And ICAO defines that we need the obstacles as point, line, and polygon. So if we, for example, we have a road, we need it as a line. If we have a railway bridge, we need it as a line. And if it is a building, we need it as a polygon. So we found this as a cost-effective method of capturing polygons and getting the boundary of the obstacles. And this data has been captured from all the NOCs which have been granted more height by conducting aeronautical study. So all of this is actually published data and it is already validated. So we do not need any more validation. So one more cost gets reduced. So the validation cost is reduced because this is already validated data published in the AIP and in the NOCs. This is the metadata, which is mandatory as per ICAO. And most of it we have actually included in our case study. So the source of the data, the accuracy, the traceability, temporality, geometry, all of this has been put in the attribute data, and we will be just showing that to you in our live data. Actually, when we create database in a GIS, then most of these things are actually inbuilt, and before we create the database, a lot of it has to be filled in before we can start creating a database in GIS environment. Lastly, I would like to do a comparison. ICAO is recognizing AIXM, which is a little bit more complicated, but and you require a special aeronautical viewer and editor tools in order to visualize. But we have started with SHAPE and SHP and KML because they are very accessible and they are more common. And SHP is also acceptable in QGIS, which is a free open source software. And of course, in the end, to be able to share this data globally, I think AIXM is the format which is going to be the global format so that all countries can share the data in AIXM. And all of these case studies that we have done for Mumbai and for Delhi are on a portal. We have developed a geo portal for viewing this database, and you can register and view it. And our colleague will be presenting that to you in a short while. And there are a few downloads which you can also take from the portal. So I will not take more time because I think the live data will be definitely more interesting. So I would like to hand over the floor now to Hemraj. Hemraj?
Yeah.
Please take over and show the portal now.
Sorry, just before Hemraj presents, I want to launch a question.
Okay.
So the question is, have you implemented terrain and obstacle database in your country? Or do you know if you have a terrain and obstacle database in your countries?
Yes, we have implemented for 5 international airports because that was mandatory. But I would say that we have not captured it as point line polygon. It is mostly point data as of now, and it does not meet the exact guidelines laid out by ICAO. So it is just the first step, and we need to go on to the next step, Antonio.
Okay, but I'm going to share the results from the audience right now. And in the audience, we have a mix of kind of 58% yes, 42% no. So it means kind of half and half about the terrain and obstacle implementation. So now, Hem, you can continue with your part.
Okay. Yes, Hemraj.
Hello, everyone. I am Hemraj Pandey, the developer of the prithipararup.net geo portal. Now I am going to show you the portal. Is my screen visible now?
Yes, it is.
Okay. Okay, this is the portal. I think. Okay, now you can visit this portal by www.prithipararup.net. Whenever you visit this portal, this is the landing page of our portal. You can see this is the main part of our portal. This is the obstacle database. We have the Santa Cruz Aerodrome database and IGI Aerodrome. Here is the download section from where you can download file from. And next section is the demo part where you can explore about the portal. And here is the demo video. You can simply open this video and go through this video how to see the database through this portal. Now, if you are a new user, you can simply register by clicking on sign up button. When you click on sign up button, you will see this pop up, and you have to enter the necessary detail on this sign up page. One thing all of you have to know about, we have restricted the other user whose Gmail from whose have not the company email. You should enter your company related email to sign up in this portal. You cannot sign up through the Gmail account created from the Google, Yahoo like platform. Okay, now as I have already account, I'm going to log in. Okay. Now I'm going to I mainly focus on this Santa Cruz Aerodrome in this presentation. This is the main dashboard of our portal. In the left section, you can see this is the layer panel. Here at the top, you can see this drop down. We can switch to another switch between the aerodrome here. And just below, you can see this is the overlay section, overlay layer section. These are the main layers we have created for tool database. At the right, you can see these are the base layer, 3 base layer option. This is the main no base layer option where you can see blank base layer. It is easy to visualize the overlay layer. And another is the this street base layer, and another is the main satellite base layer. This is the Cartosat 3 MX satellite imagery for Mumbai. And now I am going to open the aerodrome data of Santa Cruz Aerodrome one by one. Okay. Now this is the aerodrome dataset of Santa Cruz Aerodrome. You can see the attribute of this dataset by clicking on View Attribute button tool and simply click on those layers. Also, just below, we have the overstable collection surfaces, AIP appeal to dataset and terrain dataset. Now I'm going to open AIP appeal dataset, and inside this there is the obstacles approach take off. I'm going to open these obstacles. Okay. These are the obstacle dataset. As I have opened all the layers, it will take some time to fetch the data from the our geo server. Now it is loading. It will take some little bit time to load it. Okay. These are the obstacle datasets. Here you can see these are the building polygon and these are the building point. If we click on any of these obstacle, you can see the attribute of selected obstacle. You can see OBS ID. These are all the attributes are calculated by global coordinates. Here you can see these are the height, like this runway number. These are all the attributes created by the global coordinates. Okay. Now it will be better to visualize if we switch to the satellite base layer. If we switch to the satellite base layer, it will load this data again on this base layer. It will take little bit time to load. Here it is loading now. This building polygon is created by digitizing the satellite imagery. Here, this is the building polygon, and another here is building point. Building point. This is the building point we have taken from the Airport Authority of India, and here these are the attributes computed by the global coordinates. Here you can explore other database datasets. We can unselect all layer by clicking on this left side button. This is for our Santa Cruz Aerodrome, and here is the terrain dataset as well. We have the digital elevation model, contour dataset. It is taking some time to load the dataset. This is the control dataset. There is the obstacle collection surface dataset as well. You can see the dataset also, this dataset. Okay, this is for our Santa Cruz aerodrome, and another here is the IJ aerodrome, Delhi, for the Delhi. And here is the overlay layers. You can see the aerodrome data as well. For this, we have the AOI, obstacle collection surface, and Delhi terrain dataset. Here is the hide layer panel. We can hide and can see map in full screen as well. Thank you. This is from my side. If you have any question, please drop in comment section or you can ask question.
Thank you,
Thank
Hem. Actually, that was pretty interesting and showing the way that the portal worked and all of the different layers. And of course, as you have more data, then it's going to be more complicated. It's going to be requiring more resources in order to show up. So this geoportal is the end product of after you have processed something, of after you have processed the data and you want to share it to people. And before we go to Yoti, I want to launch the following question. Do you think terrain and obstacle data should be provided? And I'll go even further because sometimes you can have this sort of geoportals and visors, but should you also be able to download the data and use it for other purposes? Aparna mentioned in her first part about using AIXM, and also she mentioned about realities that it is a complex model. It has a lot of complexities. It's not easy to use because not every software is able to read the data out of the box. So maybe should we also consider using other type of formats like the shapefile, which is old, or GeoPackage or KML? I'm just going to leave that until the end, but just asking a few questions there so that people know that there's a lot of things still working out on data. And about AIXM and JFiles, those is only for the survey data, but we also have terrain, which is usually in a GeoTIFF format. So I'm going to give time for Yoti to do her part of the presentation.
Very warm greetings to all. So thank you, Mr. Antonio, for providing me this platform. So I will be showing you up the GIS part, that how we are going to create the database where we are having spatial as well as non-spatial database. So we are going to combine both in the shape files. So here, this is how the ArcGIS software looks like. So I have opened here different layers that my team member has already told you about. So here we have different surfaces, like this is IHS, this is the ICS, this is OCS, and this is OHS. IHS means inner horizontal surfaces, like that. So here you can see cluster of different data, which is point as well as polygon. So the data that I have added into this layer is it is of different obstacles like building points, tree, that you can see here in the layer panel. This is the layer panel where I have opened all the data. So we have different obstacles like tree, building point, tank, stack, pole, nav aid, natural high points, which have been considered as obstacle, and they have been included in AIP, and they have provided the details. Airport Authority of India have provided details about these obstacles. Now, let me show you that how these obstacles looks like in the aerodrome. So I have opened here Santa Cruz Aerodrome, Mumbai Aerodrome, where this is runway. This is runway 0927 and 1432. This is the runway strip, and these are the approach surfaces. Okay, so I want to show you that how we are calculating, how we are providing information through these shape files. See, we are calling these as shape files because we are creating them in form of point, polygon, and line. So if we have to capture building, then we are going to capture it as a polygon on real ground. And if we want to capture tree, and obviously tree has a canopy, but AIP is going to give you all the data in the form of point format. So here is the attribute. We have obstacle ID, we have runway area, we have obstacle type, latitude, longitude. See, latitude, longitude is the spatial information for that particular obstacle. And if we move further, we have this information, that is the remarks, where it is like where that point is on the actual earth. So this is their address for that particular obstacle. So this is again non-spatial data. So we are going to combine these non-spatial data from AIP, the handout that has already been provided to you all, or maybe later. So we are going to connect these non-spatial data and the spatial data for the obstacle through a particular ID, which is obstacle ID. So here we have created the obstacle ID, and all these obstacles have been taken from AI. So how to calculate the distances or permissible height for these particular obstacles, that I can show you. And before that, I just want to show here that there are two methods to calculate distances of the obstacle from the runway. We are going to compute distance from the runway end and the distance from the runway strip. So there are two methods. I can use the distance tool to compute the distance. See, the distance from runway end. This is runway end. And the obstacle I've taken here is, sorry, it will take, because this is huge amount of data. So it will take some time. So this is the obstacle that I've taken here is building point. So the distance here, I can calculate it manually by using distance measure tool. And here it is showing 3,743.359 meters. So this is one way of calculating distance between the obstacle and runway strip, and from the runway strip, and distance of the obstacle from the runway end. One more method is there that I can show you. So I will show you how to calculate it by using the tools. I am considering here this obstacle. See, the obstacle here is when you are going to move the cursor, you will automatically get that this is your building point obstacle. So the ID, you can get the ID by using I tool, which will give you the information for this obstacle. So here it is clearly given BABB 1624. So this is the obstacle ID for this building point. And you can get all the information here. You can get the latitude, longitude value from this particular window, and the rest of the details. So what I have done is I have used shapefile, one more shapefile. Like if I want to measure the distance, then it can be a line. So I have taken this line 1624 for this particular obstacle. What I can do is I can simply create I can simply create a field that is distance. And I need not to use this measure tool to calculate the distance. So I will create the field. The field will be distance. And I have mentioned here in this section that distance, the distance that we are measuring from where? Runway end and runway strip. So the distance is this. Okay, now I have created this field distance. For the calculation of distance of the obstacle, this obstacle, which is having ID VABB1624, I will simply run this tool, calculate geometry. See, I have different options here. I can calculate, since this is line, and line can have the dimension as the distance. So this is going to give you coordinate system of the data source. And we are considering Mumbai aerodrome. So we are coming into the zone of UTM zone 43N. And I want to calculate the distance in meter units. So it will give me the distance. So I can have the values from here, and you can simply copy the value from here, copy, and you can paste it to the Excel sheet for the further calculation. So moving to the Excel sheet, I can copy and paste the data. Let me calculate. I've taken two obstacles. So this obstacle is building point. This obstacle is building point, and another obstacle that one more thing, there is here the runway strip is 1432, because this obstacle is coming in the approach surface of this runway. So we have considered this runway for the calculation of distances from the runway strip and from the runway end. Now one more obstacle we have here is this one. So I have already selected this obstacle. This obstacle is three type of obstacle, VABB 318, which is the obstacle ID for this tree. Now we have all the other details. So again, I have taken distances, two distances, one from the runway end and another from the runway strip. This runway is 0927. So there is the different runway for calculation of permissible height for this obstacle. So here also we can calculate the distance. So again, I'm going to create the field distance. And we will calculate the geometry. So we have distances from the runway end is 624.763 meters, and from the runway strip the distance is 564.827 meters. Now I will be showing you how we are going to carry forward the calculations of permissible height from different surfaces by using these distances. So moving to, I will just copy the data from here. This is from the runway end. And this data from the runway strip. Okay, I'll share you the Excel sheet that I will be using for calculating the permissible height. Okay, so this is the Excel sheet where we have details for the obstacle, the same details that I have shown you in GIS as the attributes. We have obstacle ID, we have runway 0927, we have latitude, longitude information, and we have PE feet in unit feet. So this is actually the obstacle height, actual obstacle height that has been provided in AI, which is 57 feet for the tree for having obstacle ID VABB 318. So moving to the calculation, first layer is IHS. Since the distance is already less than 4,000, so the height, permissible height in IHS will be 45 plus aerodrome elevation. So how to get the value of aerodrome elevation? That also you will be having from EI, which has been published by Airport Authority of India. and all the data has been validated. So no need to, there is no need of QC for this data. So this is already validated by Airport Authority of India. So we have Mumbai, we are considering this special case, Mumbai Aerodrome. So the aerodrome elevation of Mumbai is 12.13 meter. So for the calculation of permissible height in IHS, it will be 45 plus aerodrome elevation. So 45 plus aerodrome elevation, we have 45 plus aerodrome elevation is 12.13, which is going to be 57.13 meters. So we have already taken, since this is in meters, we are already having this value in terms of meter. Now we have runway and 9. I've already shown you in GIS that we are taking the distance from the runway and 9. So we have runway elevation also for that particular runway and number 9, which is 5 meter. Now moving to approach surface, the permissible height in approach surface, we can calculate it by using distance from the strip, 2% of the distance from the strip plus runway and elevation. So how to calculate it? We have all the values here. So we can just distance from the strip, 2% of it plus runway and elevation. So this is your runway and elevation. So we are having the value 16.297 meter. Moving to takeoff surface, the calculation is again distance 2% of distance from the strip plus runway and elevation. So we are going to again calculate here distance from the strip 0.2% plus runway and elevation. Runway and elevation is 5. So this is 16.297 meters. So here, how to get this value? So here the permissible height is lowest permissible height of all the permissible height that we have seen here. That is from the IHS, from the in the permissible height in approach surface, permissible height in takeoff. So the lowest value here is, see, we can see 57.13, 16.297, 16.297. So the lowest value is 16.297. We can simply copy and paste here. Okay. Now, this is top elevation in meters unit. So the top elevation, actually, this is the existing height of the obstacle that we have already seen here, which is 57 feet. Now I have to, since we have all the calculation in meters, so I will be converting it into meters. So for that, we will just take the value and we will multiply it by the conversion factor. So this is the value of existing height of the obstacle. Now moving to the calculation of permissible height in OCS. So the calculation is we have to take 1.2% of the distance from this strip plus runway and elevation. So 1.2% of the distance from this strip will be plus runway and elevation. Runway and elevation is 5. So we will be having the permissible height in OCS as 11.778. Now, finally we have to calculate the penetration of the obstacle in OLS, obstacle limitation surface, and penetration of the obstacle in OCS, obstacle collection surface. So for obstacle limitation surface, we can calculate it by subtracting, taking the difference of this and this is the lowest permissible height that we have considered. So this is penetration in OLS. Now the penetration in OCS is going to be difference of existing height of the obstacle and permissible height in OCS. So we are having penetration in OCS equals to, so the penetration obstacle is penetrating this surface by 5.596 meters. Similarly, we can take, I will also show you for the another obstacle that is building and having obstacle ID VAVB 1624. Please do remember that these obstacle ID is very important for attaching all the information, spatial as well as non-spatial information, to the data set, because the main motive of creating the data set is earlier we were having this. This is we are having in tabular format and other details, but we cannot show them on real earth. So for showing them, for displaying them on the real earth, to locate them on the real earth, we are connecting them with the spatial data. So the spatial data is going to be connected by this specific obstacle ID. So I will just take the values from GIS that I have already shown you. So the value is distance from the runway end. Distance from the runway end and distance from the runway strip. Again, here also for the calculation of IHS, height in IHS, since the distance is again less than 4,000, so the value of permissible height in IHS is going to be the same. That is 45 plus aerodrome elevation, which is the same as above for the obstacle tree. So I will just copy and paste here. Okay. So moving to approach. For approach, now in this particular case, since we are having distance from the strip greater than 3,000, so in this particular approach surface, we are going to take till 3,000 meter distance, we are going to take 2% of 3,000, and then beyond 3,000, we are going to consider the difference, 2.5% of the difference of 3,000 and the distance from the strip. So here we will just take 60 plus difference of these value minus 3,000 and 2.5% plus runway and elevation. Now again, we are having different runway, that is 40 for this particular obstacle. So runway and elevation may be different in this case also, might be the same. But here we are having value runway and elevation as 12.11 meters. So we are having this as the runway and elevation. So we are having permissible height in approach surface as 89.194 meters. Permissible height in takeoff is again, the calculation is same as we have done in case of tree obstacle. So it will be 2% of distance from the strip. So 2% of distance from the strip will be plus runway and elevation. Runway and elevation is this. Okay. So we have got permissible height in approach surface, permissible height in takeoff surface. Now the lowest of all these permissible height. Here we have IHS value 57.13. Approach surface permissible height is 89.194 meter and takeoff 85.777 meter. So lowest of them is 57.130. 57.13. So this is the lowest height, lowest of all the permissible height. Now again, top elevation, which is already there, existing obstacle height, which is 190. So I just convert it into meters by multiplying with the conversion factor. P048. So the existing height of the obstacle in terms of meter is 57.912. Now for the calculation of permissible height in OCS, the calculation is again distance 1.2% of the distance from the strip plus runway and elevation. So I will just quickly calculate it. 1.2% plus runway and elevation. We are having permissible height in OCS as this. Now again, finally, we are going to calculate penetration in OLS and penetration in OCS. So for penetration in OLS, we will just simply take the difference of existing height of the obstacle and lowest. That's existing height and lowest of all. So we have penetration in OLS as 0.782 meters and penetration in OCS as the difference of existing height minus the permissible height. So we are having 1.602 meters. So the obstacle is penetrating this surface by 1.602 meter. And obviously, if this has been considered as the obstacle by airport authority, then obviously it is going to have a positive value of in terms of distance. So it is going to have, if it is negative, then it is not going to be considered as an obstacle here by Airport Authority of India. So I hope I have made it clear to all that how we are calculating permissible height in different surfaces and how we are calculating penetration in obstacle limitation surface and obstacle collection surface. So over to Mr. Antonio. Thank you, everyone.
Okay, thank you. That was an excellent presentation, which was highlighting how this process is done really from the data collection point of view. So thank you, Jyoti. That was very informative. So we're almost at the end of this webinar. Thank you all for joining us. Now, if you have any questions, this is the time for questions, answers, comments. How do you do it in your country and so forth. So I will invite you if you want to ask any question or if you want to put any sort of comments, you can do it via chat or you may request to do it live. I hope that it has been an excellent presentation for all of you until now. We have further topics in the future. I do have a couple of questions myself, Aparna. And one of them is, I noticed that in one of the images, you had a point and you also have a perimeter around it.
Yes, yes.
Why do you have both? I'm just curious about it.
Yes, Antonio, I think that's a very, very valid question. The point is from the AIP. The point is the survey data from the Airport Authority of India. And after overlaying that point on the satellite imagery, we have captured the building corresponding to that point. So there was no need to show the point, but we have just shown it. That is how we have selected the polygon to capture based on that point. So that is why we have shown both.
But honestly, I think that is an important point for everybody that is going to be watching this recording later on. Sometimes, especially when you're doing procedure design, you just use the point, but you notice that on the presentation, there's an actual area around it. And sometimes we forget about this stuff and we think, okay, the point is outside of our protection area of our ILS or our PVN, LNAV or VOR, or even about the obstacle limitation surfaces. But when you check the perimeter, maybe the perimeter is inside and it may have also the same height or elevation as the point. So that's something that we should take into consideration as well.
I just want to add to this from the mathematical point of aspect. Since the point has no dimension, actually the obstacle should have some dimension. That is why we are considering it as an obstacle. So in case of building, we are taking, since AIP has provided us the point data for the building, but on actual ground, that building is not a point; it is a polygon. That is why it has been providing hindrance to the aeronautical services and all. Thank you. This is what I wanted to add on.
Okay, perfect. Thank you, Yodi. I have another question also is, I saw that you were using like a base image of Cartosat. Is this available worldwide or just for India?
This is available worldwide. And, satellite image of high resolution is available worldwide, and I think in creation of terrain and obstacle data, it is a great resource to cut costs and to use satellite imagery as a base map. And NRSC is the National Remote Sensing Agency, is the organization in India which provides very good high resolution data in a cost-effective way. So you can check out the portal.
Okay,
Yeah,
perfect. I think Satish has a question. Go ahead.
yeah. Yeah, good evening. My name is Satish. Actually, my question is the points and polygons have shown in that what do you call, software. Those are just structures. How could you find directly go to obstacles which are actually infringing the surfaces? Do you have any color code for that?
The attribute data actually provides the penetration. If the penetration is positive, it is an obstacle. And the color code is only to delineate the type of obstacles, but you can use a color code to also only highlight those obstacles which are penetrating. So that's something that can be done in the software. We have not done it here because all of these obstacles are penetrating. So there is no, all of these obstacles have a penetration which is positive. Either they are penetrating the obstacle limitation surface or they are penetrating the obstacle collection surface. So we did not need to divide them. All of them are penetrating.
Okay, okay. Thank you. And one more thing, already you are publishing type A chart and type B and precision approach terrain chart. What is the need for complete process of this ETAT?
This database is being mandated by ICAO for multiple reasons. It is not only for creation of charts. I think it is to be used in procedure design, in collision risk modeling, in avoidance of collision with terrain. And I think there are multiple applications, and this database is to be shared with other countries also in a common format so that everybody has availability of this data. And there is a seamless merging. So that is the aim of, aeronautical information management system, which is ultimately going to be a seamless, wide network so that everybody can access that network and this data. Yeah.
Yeah,
Okay,
thank you very much. And yeah.
Yeah, just go ahead,
And
Satish.
yeah, in future, is there any possibility of merging PANSOPs and CNS perspective also to this ETAT?
Yeah,
What do you call
absolutely.
it?
ATOR data has to be given in a format where the procedure designers can and take it, directly into their design softwares and use it directly. And it needs to be updated periodically so that there is a seamless merging. And right now there is a gap of about 3 to 4 years in updation of obstacle database, at least in our country, and that needs to be reduced. So with this database, there will be a possibility of updating it much more easily than doing it in a manual way.
And thank you very much.
Okay, perfect. And to the point that Satish made, you could color code if you had the whole data set. Let's say you have hundreds and thousands of points from LiDAR or from the Cartosat stereographic processing, and then you choose just the penetrations, and you could color code them as red and everything else in green. You could do that, or any other color. But I understand that in this case, for this demonstration, you only showed the ones that are penetrating, because if not, you're going to have a lot of data. You already noticed that with the filter obstacles, just the ones that were penetrating, it was a little bit demanding on the network to try to download the information. The more data that you have, unfortunately, it's going to mean that more resources are going to be required in order to be able to process those data. So a final question, because we're almost at the mark. And this is, for example, can you use drones or AirPass to do the data collection instead of using Cartosat? Because one of the key things about terrain and obstacle databases is that you need to have continuous updates on this, at least for an area around the airport. And this can be very costly using traditional methods. And I don't know how often, for example, Cartosat is updated, because according to procedure design, at least you should do a yearly check.
Absolutely. Cartosat is actually updated every month. I mean, it's a satellite is really is continuously rotating the Earth. There is a very good frequency, but we can use drone. And only thing is that it is very cost intensive. if you use drone or LIDAR, and to get data per square kilometer is a very high cost. So cost is the biggest, deterrent today. I don't know about other countries, maybe other people can share, but it's a very cost intensive affair. So that is why we have tried to use existing databases. And as the first version, anyone can, any airport operator can do this as a first cut, to use the existing database and use data mining and some high resolution satellite imagery to capture the polygons, to capture the obstacles, the boundaries of the obstacles.
Okay, perfect. So with this, we end up our presentations for today's webinar. So thank you for joining us. Recording will be available on our YouTube channel once we process, and see you on the next one. See you.
Thank you, everyone. Thank you, everyone.
Thank you, everyone. It's very
Thank you.
helpful.